Today, we're going to be talking about FPGAs. I have many of these older FPGA boards, like the one that I have pictured here, which is an Altera DE1. And you can do a lot of things with these, because before we had things like Mister, this is what people used. So, it includes Coco 3 FPGA and other things that we can load on this. And that's what we're going to be talking about today. This is the beginning of my FPGA series. We're talking about how to do the programming of these older Altera FPGA boards on macOS and Linux, and probably also some tricks that can be carried over to Windows as well. I'm going to go over this information very quickly. I will post the slides, all the links and all this information down below in the description so that you can see all this information offline. So the software and hardware was made in like 2004. So that means that it's not really easy to get this stuff to run on modern hardware, especially if, like me, you have an Apple Silicon machine. That means that you actually can't run Intel binaries on it natively. So virtualizing is the way to go. Unfortunately, if it's virtualized, that means that it can work on an Apple Silicon Mac, it can work on an Intel Mac, it can work on regular Linux, and it can also work on Windows. So on Apple Silicon, I'm going to be showing today UTM and QEMU, but you can run QEMU on pretty much everything, Intel Macs, on Linux. You can even run QEMU on Windows, so this will still work there. You can use any kind of commercial software, VMware Fusion, VMware Workstation, Parallels, VirtualBox, KVM, Zen, etc. Any virtualization platform that can run Intel x86. So the Linux distro that we're going to use inside of this virtual machine is called macOS. And macOS is it's not really a stripped down Linux distribution. It's a Linux distribution that's made for what they call i686. So the Pentium 2 and Pentium 3. And it's most importantly, it is a 32-bit operating system, but it has all of the modern software in it. So when we get in there, we're not really going to be feel like we're missing anything. We feel like it's all there. Everything is there. But you could use almost any other Linux distribution as long as it still has i386 Intel support. And I'm not going to explain how to do all of that work. You have to do multi-arch and add i686. All of that stuff is beyond the scope of this video. Debian and Ubuntu should support that. I am assuming there's a way to get multi-arch type of support in other Linux distributions. I'm not familiar with that, and again, I am not covering it here in this video. So we do need some software for programming tools. We need an old version of Quartus. Quartus Web 13.0 Service Pack 2, I think this one actually is. The easiest way to get a hold of this is just go straight to Internet Archive. You can download it from Intel's website, but you have to sign up and click this and click that and blah, blah, blah. Internet Archive, you can just download it straight. If you want all of the manuals and documentation, they're on the system CD, which you can still download from the manufacturer's Terasic website. And we're also going to use MikeyN6IL's tools. So in this particular demonstration, I'm not going to use the GUI. We're going to do everything from the command line, with a few simple scripts that I've written that make it very, very easy to program the FPGA, load a soft file, program a soft file in the configuration device, and even load the ROMs. It's very, very easy. You run some short commands and it all works, and you can pretty much ignore all the GUI stuff. You need the actual FPGA software or firmware itself, Cocoa 3 FPGA. The latest version is 4.1.2. Many people are just running 4.1. I've been playing around with PaceDev, which is an old project by Mike McDougall. I've been playing around with PaceDev, which is an old project by Mark McDougall, which has a lot of things that you can run on a DE1 or DE2 board. There's also a multi-comp, which is pretty interesting. So there's a lot of different things that you can actually run on these older boards. It's not going to be as slick and as easy as using a MiSTer will be, but it's out there. Okay, now the required hardware. Of course, today we're going to be playing around with a Altera DE1, like this one here. The same tricks will work with a DE2. Pretty much any board that has an Altera on it. Even if you make your own like multi-comp board, the same thing will work as well. The DE1 and DE2 specifically have a USB-B connector that is how you connect to the Byte Blaster to upload the data to the FPGA. You also need a good quality USB serial adapter. FTDI-based boards are recommended because they work really well. If you do not have a DE1 or DE2, you do need to get an Altera Byte Blaster, and you need the appropriate cabling for that. Of course, you need a VGA monitor and a PS2 keyboard. So these are all prerequisites. They're all things that you need to have in order to get started. So given that you have all of these things, next we're going to show how you actually create the virtual machine, install all of the software, and I think in today's video, we're just going to do a very brief overview of how you do this, because there's a lot of steps and a lot of detail that you can get into. I'm going to go over it very quickly. I can probably make a more detailed video to show every single possible step at a later time. So first, let's start with UTM. We can literally click a button, create a new virtual machine. We're emulating Linux. They ask you to browse to the ISO, which is in my downloads folder somewhere. Okay, here's the macOS ISO. It's not really going to know what this is. We just continue. So we don't want x86-64. We want i386. Standard Q35 PC is fine. We don't need 4 megabytes. 1 megabyte is plenty. 2 CPU cores is good enough. We will do additional configuration later. 64 gigabytes disk image is too big. 40 is probably enough. Shared directories are not really going to work. It may be possible to install those tools, but I'm not sure. And we're going to call this macOS demo. We do want to open the VM settings before we go too much farther. We want to just double check the CPU that we want to use we want to use a Pentium 3 CPU, which is actually the lowest CPU that the Quartus software will work with. So we just select that. We need to make sure that We are not using UEFI. This is actually important. Don't need a PS2 controller, but we don't need UEFI. That's way too fancy for us. Okay, so these are the settings that you need to set in UTM. You can basically click at this point, click play on this, and it will bring up the window and start up. Now, I'm actually going to show the shell version of this. Okay, so we have our macOS ISO, we have our disk image, which I've already created. This script actually creates it for you, creates a disk image, and we have the same settings that we just saw in the GUI. We have the Q35 chipset-based machine with the Pentium 3, 2 sockets, 1 megabyte of RAM, 1 megabyte of RAM, 1 gigabyte of RAM. Boy. Whew. VGA controller, Ethernet controller, USB keyboard and mouse, USB controllers. So this line here is something important. This particular line here actually does the USB pass-through of the Byte Blaster. If you're using UTM or VMware or one of the other solutions, you can literally just click on the menu and go find the device. When you're using QEMU, you can't do that. You actually have to look up the vendor ID and product ID of your device. And this is how you actually pass it through. And we attach the CD-ROM and the hard drive, and we're ready to go. So at this point, we can just run this. And our window should pop up here. All right. This is going to take a little while to boot, so I'm going to do a cut when that is ready to go. All right, we have macOS booted up. There's not really that much we need to do except just start the installation. So we can just click that. The installation will take some time. Need to enter the default password here. And as it says, do not close this window. You should follow instructions and do not close the window. I will walk through very quickly how to do the install. It says we're using BIOS and they're going to use Grub version for BIOS, which is fine. It's not necessary to create a separate boot partition. That just makes things a little bit more complicated. This is just showing what disks we have. We have SDA, which is the disk we're going to be using. We can just run gparted. It's very easy. Create 1 or 2 partitions. So we have a 40 gigabyte disk. Create partition table. We can just use the MS-DOS partition type, which allows 4 partitions. Now we can create a new partition. New size. We can just basically leave with the default. It should be fine. It'll just use a swap file. So we just have to create this one partition and we're pretty much done. Apply all operations. Are you sure? Yes. We'll create the file system. Okay. Looks like we're done. Just follow the instructions, put the boot on the master boot record, on dev SDA1, install the operating system on dev SDA1, ext4, it's probably going to reformat it. Yeah, and we say proceed with the installation. Oh, time zone. I'm in US. And I'm in Pacific New. I think it's going to ask us about the keyboard, and that's pretty much it. Yeah, locale, the default is going to be English, just passed it. English, US, UTF-8 is the default. Just leave it at the default is fine. It's asking us about the keyboard. I normally just select generic 101, English US, and usually put right Alt as the compose key. I think that's it. There's a message here in this window. Already contains a file system. Do you want to proceed anyway? Just type yes. And now it's installing. So this is going to take quite a while. We'll come back when it's actually finished copying files. After a couple of hours, it finished copying files, and now it is asking us if we want to install the bootloader. So let it install the bootloader. The default user is Psychos, so we want to permit sudo and keep the root account. Doesn't really matter. This is just going to be a local account. Root password. User password. Don't really care. The default is Linux. Installation complete. Please remove your media and reboot. Rebooting is going to take a while, so we'll see you on the other side. So it seems to be sitting here for a while doing nothing. I think we just help it out and hope for the best. It says display output is not active. Here we go. So while I'm here and I'm restarting, I'm changing from the Psychos boot CD to the Quartus one. And we run this again. And of course, it will take a while to boot. Default login is Psychos, and so we didn't change the password. It's Linux. It should be up and running in just a moment. All right. So now that it is up and running, we get to move on to the next part. And that next part is installing Quartus. So the CD that we attached is right here. And we just run setup.sh, and that should kick off the process. Yay! Set up Quartus. Next. Accept. Next. Let it install into the default location. Install all the default options. We pretty much want Cyclone 2, 3, 4, and 5 anyway. All right. This is going to take yet more time. So I'll cut here and we'll come back when this thing is done installing. 3, 2. All right. So some time has passed and now it looks like the installer has finished. So we're going to let it create the shortcuts and launch the program just to prove that this thing is working. So I'm just clicking finish over here. And it should start up Quartus in a very short bit. I know that there was some error. Window below down here, not sure where that is. Oh. Okay, it said it failed to open the web browser. Alright, that's fine. Okay, so we're not going to buy the software, we're just going to use the web demo. So you just click run it. And we can say, don't show this screen again. And here we go, Quartus. So there is one thing that we need to do before we can actually use this thing. We have to do one setting inside of the Linux VM so that we can actually access the hardware. So if you look at this page here, what we need to do is essentially we need to give permission to users to set up we need to give permission to the regular user to be able to access the USB device. So we just need to make these settings inside of the Linux VM. Okay. So I am going to do that. I'm just going to save this on my local computer, and then I will get it transferred over to the virtual machine so that we can get these settings set. I am all set for this now. So we want to go back to, okay, we actually don't need quite this, so let's get rid of this. I have the blaster.udev, and if we take a look at the instruction scan, what we want to do is we want to make these a file 92 USB blaster.rules. Okay. Okay. There we go. Now we're going to need to reboot one more time, but before we do that, I'm going to do one more small thing, just to make sure. If I look at the list of USB devices, we definitely see that the USB blaster is here, and it's in our list of devices. So this should be correct, and it should work. So we just need to do a quick reboot, and those settings should be active. All right, I'll be right back after we reboot this thing. So we're done with that reboot, and now we can continue trying to get this thing configured. Now we need to install a bunch of stuff. First, we should update all of our repositories, which will take a little bit. Okay, we're installing Git and SSHFS, both things that we need. All right, now that we have that, I don't like typing my password all the time, so just create a passphrase, put a password here, and then SSH copy ID. Okay, well that's good. Okay. Here we go. Now I have access to everything on my Mac. It's just done over SSHFS as I showed just a moment ago. Easy way to get access to stuff. Might be a tiny bit slow, but it should work. All right. So now we're going to talk about my project called Altera CLI Tools, which I have right here. So as it says here, Altera CLI Tools is a set of wrapper tools around some parts of Quartus in order to program, in my case, the DE1 and DE2, but it can program anything that uses Quartus and the Altera Byte Blaster tools. The important thing that you need to know about this particular project is you have to run this command before you run any of these other tools. Let's go ahead and do that before we forget. So we need to run is home Altera 13.0 SP1 NIOS 2 EDS, and we just run this NIOS command shell. And now that we have this, we actually have access to all of the Quartus tools. They all run, and we're all set. So here's what we have in the Altera CLI tools. We have a way to program. The script is actually called ROM program. This actually does the same thing that you do when you use that control panel application. It actually loads up NIOS into the board, and then it programs the flash. So you can use this to write the ROMs into your board. It's pretty simple. You basically say ROM program, the file, and the address. And that's it. You run it. It programs the flash. So there are two ways to load things into the FPGA. Soft load and soft program. So soft load does what I'm going to call a soft load, and not soft SOF, soft soft SOFT. So what this does is this loads the soft file into the FPGA without making it permanently programmed. The soft program utility actually writes it to the configuration device on the board. If you write it to the configuration device on the board, then that makes it permanent. That means when you turn on the board, it loads whatever is in the configuration device. Whatever you program in with soft load is just temporary. So these are the three main commands that you use to program things on the these are the three main commands that you use to program things on the FPGA board. All right, let's go back over to here. So let's just start out with soft load. I have a bunch of old versions of Cocoa 3 FPGA here, but I'm going to make a copy of this onto my desktop so we can play around with it. Okay. So this is Cocoa 3 FPGA version 4.1.2, which is the absolute latest one. And they have different versions depending on what hardware you have. Old versus new. They made a production change in the DE one. The newer boards have a different RAM than the older ones. So my board that I have here is is old add. So I just cd to this directory. And the soft file is here, this one. So I could just program this up. Whoops. I'm going to load it first. This is really all I need to do. I don't need to mess with any GUIs, do anything. I run this command. If it has access to the programmer, says programming cable not detected. Okay, so we may need to do something and come back to this. All right, I simply had to reboot. So now let's get back to this. We have our soft file and we simply run the soft load program to load it soft into the FPGA board. Again, when you power it off, it's going to forget this. This is not permanent programming. So you can use this to temporarily load something to see if it's going to work, if it's going to do the right thing. So let's go ahead and do that. Altera CLI tools bin soft load Cocoa 3 FPGA DW.soft. And now when we do this, it's actually going to talk to the FPGA board and do the loading. I'm not going to show what this looks like at the moment. That's not part of this particular demo, but just showing an example of how you can load things into it. Okay, and if you want to do the ROMs, we have that as well. Okay, so we do need to take a moment and have a look at the Cocoa 3 FPGA instructions. Which I do not actually have handy. So files area. We can just look at this one, Cocoa 3 FPGA.pdf. All right. So by the way, if you're playing with Cocoa 3 FPGA, you do need to read this document to understand all of the switches and buttons and everything, what they all do. But what's important is we need to look at the ROMs. The ROMs for the Cocoa 3 FPGA are the original Cocoa 3 ROMs with no modification. And it says they should be programmed with the control panel application. And you can use that control panel application to program the 32K Cocoa 3 ROM starting at address 0. All right, so how do we do this? This is where, so if we look, we have coco3.rom. It is 32K. So we can just program this up. So if you remember, ROM program, we need the name of the ROM file and the address. And looking back at the documentation, we do need to note that it has 1, 2, 3, 4, 5 zeros. That's important to know so we can get that right. So we run ROM program, coco3.rom, 1, 2, 3, 4, 5. We hit enter. And what this is going to do is it's going to do the same thing that the control panel does. First, it's actually going to load MikeyNS operating system, soft load, temporarily load it into the FPGA board, and then it does the programming. I already have it on this particular board, so it said erase not required, no change to device contents. Okay, so that's part one. In order to actually use this, we also need to have the disk controller, which is a little bit farther down. MPI slots. Normally on a Coco, the disk controller is in slot 4. So slot 4 is used for the disk basic ROM. This is an 8K ROM programmed at 08000. Okay. Easy. Okay. So we have disk11.rom. So again, macOS Altera bin ROM program disk 11, and he said the address is 08000. And we just run this. ROMs are programmed. And then we just need to go back and configure the configuration device. So before, what we demoed was we demonstrated soft loading using the soft load. Now we're going to do soft program, which just programs it into the configuration device. And when we turn this thing on, it's going to be a Coco 3 FPGA. That's it. Run this, hit enter. And it does all the things it needs to do the programming. It looks like it's doing it. All right. So this is how you do it under macOS, and you can also do the same on Linux using a virtual machine to program old Altera devices. So I'm going to go a little bit more in depth about the Coco 3 FPGA, its features and settings and other things. But this is the prerequisite, the setup that we need to have in order to program and use this thing. So hopefully you look forward to the next hopefully you look forward to the next video in my FPGA series where I go more in depth about the Coco 3 FPGA. Bye for now.